Okay, so on this homework, it's 1.5B part 1, and it's question 3B. And the question was, what do you do about like having 3 in the denominator? Well, I could actually write that as 1/3 x instead. So the thing to think about is what's being affected when I have my value in parentheses like that. It's affecting the horizontal or the input. So I would have a horizontal stretch, because remember, we always do the inverse thing that it appears to be. We're kind of like forcing this back to be the original parent of x, whatever the function is. We have a picture here, but we don't really know the equation. We're just saying perform these transformations on this particular graph. So on this tells me horizontal stretch by 3. Okay, so I'm going to multiply any x values on here by 3. Okay, so multiply x's by 3. Just to make myself a little note. And then here on the +1, that's outside the parentheses, that's affecting my output. So it's a vertical thing, and it's a plus or minus, so it's shift, and it's up 1. I'm going to add 1 to y's, because for vertical or for output, I just do verbatim what it says. It's not a opposite or inverse thing happening. So now when I go over here and look, I'm going to kind of pick out my key point. So I would have 0, 0. You can do it right on the graph if you want, but you might like to pick some points that help. So like I would have a half and 1. I would have 1, 0. I also have 1.5 or 3 halves. -1, and I have 2, 0. So then I'm going to look at what's happening to each of these things. So I'm going to do the x part first, because that's a stretch. So I want to always do my stretches before any shifting, just to be sure. If you have 2 different things going on, it really probably would be fine, but we want to just get in the habit of that. So if I have horizontal stretch by 3, I would multiply all these x's by 3. So that's still going to be 0 there. This will be 3 halves. This would be 3. This would be 9 halves. Okay, and the 2 would become 6. And then on the right column there of my points that I laid out, I would be adding 1 to all those y's. So I'd have a 1, I would have a 2, a 1, a 0, and a 1. So I'm going to go ahead and plot this. This is my new x and my new y. So I would have 0, 1. So really you can do it as you're working. Like I could say, okay, that's my original, right? I'm going to multiply by 3, which would still be 0, and then shift up 1. Okay. The next point, multiply by 3, which gives me 3 halves. So that's like 1.5. And then for my x, sorry, I have to move over this way. So if I have a half, now it's 3 halves, and I shift up 1. So see how I can just kind of move it over this way and then up 1 and then plot. And now for the 0.10, again, I'm multiplying by 3. So now that's going to go over to here to be on 3. And then I'm going to shift up 1. So I don't really actually want to write that one in or any of these lines. I just want the dots. So see how it's kind of stretching horizontally, right? Rather than scrunching up. And then once you get the general gist, you can just kind of go for it. But I'll plot them in a little bit better so we can see. So we have 9 halves would be out here, right there, and then I'm going to shift up 1, So I'd have 9/2 and 0 right there. And then I would have, the original's down there, 6 would be way out here. And then I would be up at 1. So I was pretty close on my little. Okay, so that is stretching out. So it's all about this. If it bothers you to have like a divide by 3, then you can write it as 1/3 x. But it's fine. You're not factoring anything there, so it's okay. You could just think of it as, if I'm dividing, I do the inverse thing and multiply and get that stretch on it. Okay, so the other question was 1.5 part 1. For V, and then also, 5 and 8. So we'll look at this one first. So we're working off this graph, and if we perform this operation here, then these transformations, we would have to pick which one happens. So I think what's throwing you off is having something in the denominator like that, but this just means output divided by 2. Cut in half is the same thing. So whenever you see it divided, you could always just write that as, you could write it as half f of x. Okay, so anywhere I have the points that for my y values, if I were to cut them in half, because remember, when it's outside the parenthesis here, it's affecting the output, right? So it's half the output. So in that case, let's see if we have the one. All right, again, picking some key points on here would be really good to give you a handle on which graph to choose. So I'm picking ones that are on corners, so they're just really easy to tell. So this would be 0, 1. And then I would have 1, 2, 3, 4, 1. Okay, so let's see what happens with any of these. I'm thinking this is a vertical compress by a half. So I know it's going to kind of squish down vertically. So even just without doing anything, I'm going to say it's probably this one, because that one it doesn't have any flip. It's the same general shape, except it's kind of squished in height, right? So that's the only one it really could be, I think, at all. But let's double check that and make sure. So my y's would have to be cut in half and my x's would stay the same. So I should have a 0.4 1/2. And let's see if this one fits. 1, 2, 3, 4 half. Yeah, perfect. And then the same thing here. I should have a 0 1/2. And I do. So my guess is correct. On 8, that's another one that was asked about. And this means that there is a reflect on the, or horizontal reflect. So all the x's are going to become negative. So it's going to reflect over the y-axis. Okay, so my inputs are going to end up being the opposite sign from what they originally were, right? So, and I also have a shift, a vertical shift up 2. So again, I can kind of look at these key points. The first thing I need to think about is this hump is going to switch, sides, right? So which ones have a reflect? I would think of like F has a reflect that way, kind of bringing, if you were looking at a mirror and kind of flipped it around. So the F could be a possibility. I could be a possibility. Or you could narrow it down. This one doesn't, I don't know what that one is. Could be, but this one for sure, no. No. You can narrow them down a lot. Okay, so I'm gonna look at these two because that's what I'm thinking. But I also, not only do I have to have that reflect, I have to have a vertical shift up too. So my points, if I reflected on there, I would have to have a well, 0, 1 would still be on there, but then up 2. So I would have to have 0, 3 on that graph. And I would also have to have a -4, 3. So let's see how those fit. So F is out because I don't have a 0, 3. So that's out. But I do have a 0, 3, and I also have a 1, 2, 3, 4, -4, 3. And then I could check some other points. You know, you could kind of judge it, but I would be the one for that. I guess it was 7 that was asked about. Whoops. Well, that was a good one too. I will do number 7 now. So let me look at number 7, and I will get rid of this mess here. So in this case, we have 2 things going on. We have a flip, right, or a reflect, and it's affecting the output. So that means my Y's are opposite sign, or, you know, multiplied by -1. So I have that reflect over x-axis. Okay, when my Y's go down. So that is one thing that has to happen. And I know these 2 are out because I already used them. And then inside here, again, I have that negative F on the outside, but inside I have x over 2, so I could write that as half x, which just means I'm going to have a horizontal stretch of 2, because it's the inverse thing, right? So I have 2 things going on. I have my reflect, so I have to think, how did these points come around the other way? So this would have to end up having a -1, but it would also have to be a stretch of 2. So if my point is 0, I would have to have 2 times 0, which would still be 0, and then this point would become -1. Now here's where we can really look at it. This 4 would become a 8. So that's going to really stretch out. And then this 1 is going to become a -1. So we have 4, 5, 6, 7, 8. So it's going to be out here. Okay. And remember, it's all upside down. So all these are going to come down. So it's going to be something like this. So let's see what we have. That would be looking like that one at all. I need to come down. Let's get a couple more points. So because this one cuts off, I mean, I think I am pretty okay with how it goes, but it gets cut off. So we just want to double check a couple points. So this one's pretty close to, it's not quite on the corner, but we'll say that is the 0.22, or pretty close to it. So we would have to multiply our y by -1, so that would bring it down here, and then our x would be 4. Okay. So it's a little off, but So kind of like that. And then if I were to continue on that kind of vein, trying to get maybe a higher point, but not too big, because, you know, multiplying by 2 is going to double everything. So if I have, this is at 1.5, negative 1.5. And if I double that, I would be at negative 3, and my y value is just 0, so that kind of stays. So that's kind of a good one. So 1, 2, 3. Yeah, so write out like that. So that one, to me, the piece that is showing in the graph looks like E. And I hope that helps figure out like how to kind of use those key points and look at what the transformations are, and make sure whenever it's inside the parentheses, like right here, that's affecting the input. So if it's being divided by 2, you multiply by 2. If it's half x, it would become 2x. So it's a horizontal stretch, and you can see how that stretches out, pulls out kind of sideways.